Nowadays, deep learning models have taken the world by storm, revolutionizing fields like image recognition, speech synthesis, and natural language processing. So, among these advanced algorithms, three standout are particularly transformative. That is gated recurrent unit, recurrent neural network, and long short-term memory. So today we will understand what makes these models so revolutionary. So let's get started. The first is gated recurrent unit. Well, a gated recurrent unit is a type of artificial neural network structure which is used for processing sequential inputs such as speech, text, or sensor signals. It has the memory capabilities that allow it to remember important details across time steps and decide whether to pass them forward or discard them. Well, gated recurrent units can be particularly effective in analyzing long-range dependencies between input elements, which makes them useful for various industrial applications such as predictive maintenance, quality control, and anomaly detection. So imagine you have a manufacturing plant which is producing items in batches. So the sensors installed throughout the production line monitor various parameters such as temperature, pressure, speed, etc., generating continuous streams of numerical readings. And these data points need to be analyzed comprehensively to detect any abnormality which is signaling potential equipment failures, product defects, or safety hazards. So to do this job efficiently, a sequence of sensor measurements needs to be fed into a gated recurrent unit based algorithm. So depending on historical context, this gated recurrent unit decide which past observation should be carried forward and added to the current ones for forecasting future trends accurately. So if something seems amiss, the gated recurrent unit highlight it as an unusual pattern requiring further attention. So consequently, engineers can react proactively before costly downtime occurs. So overall, this gated recurrent unit offer immense potential for enhancing operational efficiency, minimizing waste and maximizing profits by optimally balancing resource utilization against performance standards. Next comes long short-term memory. Well, this long short-term memory networks are another powerful variant of artificial neural network which are specifically designed to handle sequences of variable length, which enables them to process long-term dependency in temporal data effectively. So unlike traditional recurrent neural network, which often suffers from vanishing gradient issues leading to degraded performance during training, long short-term memories possess a special cell state mechanism that allows them to preserve critical information over extended periods. So to illustrate how a long short-term memory works, consider a scenario in finance where stock prices exhibit periodic fluctuations around a trend line. So a long short-term memory could be employed to predict price movements based on historical time series data. So at every step, the input price value is multiplied element-wise with the weighted forget gates to selectively keep or erase previously learned internal memories. So subsequently, these retained values are combined with new input and output candidate vectors to produce fresh hidden states via sigmoidal activation function. Finally, gate outputs determine what gets passed forward to subsequent iterations while filtering out irrelevant noise. So by learning to manage its internal memory dynamically, long short-term memory excel at capturing subtle relations among distant events in dynamic systems like financial markets, weather patterns, traffic flows, or biological processes. And in industry, this long short-term memory find widespread use in numerous domains ranging from fraud detection, supply chain optimization, demand forecasting, energy management, and healthcare diagnostics. Next comes recurrent neural network. Well, this recurrent neural network is a specialized type of machine learning algorithm which is capable of handling sequential or time series data. Essentially, it is an extension of conventional feed-forward neural nets where the same set of weights is reused across multiple input samples instead of being reset after each calculation. And this ability to maintain a persistent state enables recurrent neural network to remember crucial information over time and draw connections between related pieces of evidence and hence making predictions about future events based on history. In practical terms, this recurrent neural network enable intelligent machines to understand natural language text, recognize spoken words, translate languages, play video games, generate music, analyze genomics data, interpret medical imagery, and drive autonomous vehicles, among many other fascinating tasks. For instance, suppose we want our system to identify which customer reviews are most helpful based solely upon the unstructured text content provided. Then an recurrent neural network trained on large corpus of labeled example will automatically discover the essential features and relations that distinguish informative critics from the less valuable ones. So once learned, the resulting model can then make accurate recommendations whenever faced with novel cases never seen before. So by modeling complex causality structures inherently present in real-world phenomena, this recurrent neural network represents a major advancement towards building truly intuitive and responsive cybernetic entities which are capable of interacting intelligibly with humans. Thank you.